Today in Math 30-1, we're looking at topic 10.1, the sums and differences of functions. If we look at adding two functions, f of x and g of x, we're going to call it a new function, h of x, where h of x is going to be written as f plus g of x. Two functions, when we subtract them, f of x minus g of x is going to result in a new function, h of x, where we're going to write h of x as f minus g of x. An example 1. Let's say f of x was equal to 2x plus 1 and g of x is equal to x squared. Determine f plus g of x. Well, all we simply do is say h of x is f plus g of x, which is 2x plus 1 plus an x squared, and h of x will be the combined function x squared plus 2x plus 1. Part B, to sketch the graphs of all three on the same set of axes. You're going to notice that when we plot some points and you derive the points, x is negative 2, 2 times negative 2 is negative 4, plus 1 is negative 3. Negative 2 squared is positive 4. If we added those two, negative 3 plus 4, you get 1. Similarly, negative 1 times 2 is negative 2 plus 1 is negative 1. Negative 1 squared is 1. And when you add those two, you're going to get 0. Same goes for all of the rest of the points. Notice on the last one, when x is 2, 2x plus 1 is 5, x squared is 4, and the composite function is 5 plus 4, which is 9. Here's a picture of our graph. Notice that in red we have our combined function of h of x equals x squared plus 2x plus 1. C. State the domain and the range of h of x. Well, it's quite simple actually. The domain of the combined function has to be determined by the domain that's common to both of them. Here, f of x can be anything, so it's x equals r. G of x can be anything, so it has domain x equals r. And so h of x is going to have the domain of x equals r. The range we can read from the graph, and that is going to be the y is greater than or equal to 0. Part D. Determine values of f of x, g of x, and h of x when x equals 4. Well, we're simply going to do some substitution on all three. And if f at 4 is going to be 2 times 4 plus 1 is 9. G of 4 is going to be 16, because 4 squared is 16. And h of x is going to be 16 plus 8 plus 1, which is 25, which is the same as adding both of these separately. Here in example 2, we're going to look at the difference of functions. Consider f of x being root x minus 1 and g of x being x minus 2. To determine the equation of the function h of x is f minus g of x, we're going to have to take the x minus 1 minus the x minus 2, which will simplify to be h of x is equal to the root of x minus 1 minus x plus 2. Let's sketch the graph. Again, we're going to plot some points for all three. We pick these x values for the root of x minus 1, x minus 2, and the root of x minus 1 minus x plus 2. First of all, negative 2 minus 1 is root negative 3. That, of course, is undefined, which makes our composite function undefined. Negative 1 minus 1 is root negative 2. And 0 minus 1 is the root of negative 1. The first time our function of root x minus 1 is defined is when x equals 1. because then I'm going to have the square root of 0, which is 0. For g of x, I am going to have 1 minus 2, which is negative 3. Oops. 1 minus 2 is negative 1. And for 1 minus 1 is going to be 0. Minus negative 1, which is positive 1. Now I have 2. 2 minus 1 is 1. Root 1 is 1. 0. 1 minus 0 is 0. For 5, I get root 4. Root 4 is 2. And that's 3, which is negative 1. And then when I have 10, the root of 10 minus 1 is root 9, which is 3. 10 minus 2 is 8. And 3 minus 8 is negative 5. Now I can plot some points. And here's the graphs, where I'm showing that the red graph is my combined function h of x, which is root x minus 1 minus x plus 2. To state the domain of h of x, we can first of all say that the f at x has the domain of x being greater than or equal to 1. G of x is going to be any real number, so that means that my combined function h of x is going to be restricted by the domain of f at x. The part that's in common to both is going to be just the part where x is greater than or equal to 1. If we use the graph to approximate the range, we will say that it looks like y is going to be less than or equal to, well, it's bigger than 1 but less than 2, so I think it's going to be about, y has to be less than or equal to about 1.2, and it can be any real number less than that. In example 3, now we're asked to come up with a combined function from the graph of two original functions. Well, to do this, we're going to gather some points up. What we're going to say, first of all, is the points that are on f at x, the points that are on g of x, and f plus g of x. So if x is negative 4, notice that our function f at x in blue is at negative 3. G of x is at 1. When you add those 2 points together, you're going to get negative 2. If x was at negative 3, f at x is going to be at negative 2. G of x is at 0. That's going to add up again to negative 2. I think we see a pattern here. Negative 2 is going to be negative 1, and negative 2 is going to go to negative 1, so that's going to be negative 2. Matter of fact, for all of these points, our combined function in green, which I'm going to put in green, is going to be f plus g of x as a value at negative 2. In example 4, we have a problem. Reach for the Top is an academic challenge program offered to students across Canada. Suppose the cost of t-shirts for the program include $125 in fixed costs and $7.50 per t-shirt. T-shirts are sold for $12 each. Write an equation to represent the total cost C as a function of the number N of t-shirts produced, and write an equation to represent the revenue R as a function of the number N of t-shirts sold. Well, to do that, what we're going to say is that C of N is going to equal 7.5 N plus 125. That's our cost function. Now our revenue function, R as a function of N, is going to be 12 N, or 12 for every t-shirt sold. B. Graph the total cost and revenue functions on the same set of axes. What does the point of intersection represent? Well, the point of intersection is always going to be where the two functions are going to be equal, and that's where the costs are going to equal our revenue. And on a graph where costs equal revenue, that's your break-even point. C. A profit is the difference between revenue and cost. Write a function representing P in terms of N. So if profit is equal to revenue minus cost, we can say P of N is going to equal our revenue, which is Rn minus the cost C of n, which is 12n minus 7.5n plus 125. To simplify, that would be 4.5n minus 125. Part D. Identify the domain. Well, in simplistic forms, the domain n is the number of t-shirts sold. It's got to be greater than or equal to 0. It can be any whole number because we're not going to sell 1.5 t-shirts. The domain is going to be, the revenue has to be n is greater than or equal to 0 because the least amount of money we can make is 0. And the domain of the profit is going to be n is greater than or equal to 0 for n is any whole number.